Good morning, everybody. Hey, I'm coming to you with a functional equation. Now, this is an equation where we're actually looking for an unknown function. We're trying to find a function, not a number, or scalar, or an integer, or complex number, anything like that. We're trying to find a function. Now, these type of problems often involve certain types of algebraic manipulations where you try to eliminate pieces of it and solve for the unknown function. This one's different. This one's more of a pattern recognition or just a recognition depending on your background. So if it's been a while since you've had certain math courses, you may or may not recognize this form. So let's just go ahead and get started with the approach here on for this particular problem. Now it's often the case you're better off clearing out the fractions. So we're going to do that right now. You can write this as if you multiply everything by 3, you would get 3 f of x. And again, y'all, we're looking for a concrete function, f of x, that satisfies this. So multiplying everything by 3, this 3 will cancel, so you'll get f evaluated at 3x. Now, there is some temptation here to cancel this 3, but remember, we only cancel this 3. This 3 is actually part of the input to this function. Okay, now right here we'll have 4. And I like keeping the parentheses here, folks, just my preference, because we are cubing the function itself, not cubing x, we're cubing the function itself. All right. So at least now we have an expression that that doesn't contain fractions. Okay, now again, if you know where I'm going here, some of you may already know the answer, but this is a matter of writing it in a form where you would recognize it from some of your coursework or just some of your math background. So what I'm going to do at this point is I'm going to subtract this term from both sides, and maybe it'll become recognizable at that point. Maybe it already is, but we can write 3f of x minus this piece right here, 4 . Now, this process isn't like the standard functional equation where you have a bunch of algebraic processes you go through to eliminate things. This is just about recognizing a form. Okay, now, so we've rewritten this with two relatively straightforward algebraic steps. Now, the key aspect right now is have you taken trig recently, and how far did you go with it? Because if you remember, identities were a real big deal in trigonometry, but it turns out there's an identity in trig where, and it takes a few steps to prove it using the addition formulas and the various other Pythagorean identities, but this is actually the sine of 3x okay, sine of 3x. And y'all, they're a little sloppy in the trig notation, in my opinion. They'll write it like this. I'll go ahead and switch to that notation here. And I've never liked this notation, but they just do it in the name of brevity, I guess. But they'll put the cubed right here, which indicates you're cubing the function. Okay. Technically, I would write it like 4 sine x in parentheses and then cube, just like this. All right. Then right here, this is 3 sine x. And this is a pretty well-known result from trigonometry where you write sine of 3x as a polynomial. Okay, you can think of this sine of 3x as a polynomial in the variable sine x. All right, and that's sort of a big deal in trigonometry. But anyway, by inspection here, our unknown function, our answer is going to be f of x equals to sine x. Yeah, I know that's kind of a sleazy problem in a way because you know, you either know this or you don't. You'd never be able to manipulate it otherwise. But it is an example of a functional equation nonetheless. So the solution is this circled object right here. That's the solution to this functional equation right up here. Okay, just like if you got x equals 5 or something, here you got f of x equals sine x. So this is the solution to that functional equation. Hope you enjoyed. Let me know if you have any questions or want to see similar problems worked.